Hey everyone, and welcome to this explainer, brought to you by Forge College. Today we are sketching out a really fascinating engineering puzzle. We're going to take Ethereum's notoriously heavy regulatory red tape, and we're translating it into high-speed Solana code. Specifically, we're zeroing in on the ERC-3643 security token standard. Now, if you've been following our track on moving from EVM to SVM, you already know this isn't just a simple copy-paste job. No way. It is a complete architectural rethink, kind of like drafting a brand new blueprint from scratch. So, let's get our bearings and see how we map the strict, rules-heavy world of security tokens onto Solana's blazing fast architecture.
Which brings us to the million-dollar question, right? How exactly do we take slow, rule-bound, real-world bureaucracy and shove it onto the absolute Wild West that is the Solana virtual machine? All without, breaking everything in the process. Ethereum handles this using complex smart contracts with all these built-in hooks. Solana, on the other hand, is built for pure speed and parallel processing. It kind of hates bottlenecks. So marrying strict regulatory compliance with the SVM, well, that requires some incredibly clever engineering.
Think of our agenda today as our engineering schematic. Here is the blueprint. First, anatomy of a security token. Second, the translation mental model. Third, EVM versus SVM mapping. Fourth, the upgrade factor. And finally, next steps.
All right, let's dive right into Section 1, Anatomy of the Security Token. We really got to understand the nature of this beast before we even attempt to port it over.
So the absolutely crucial thing to grasp here is that an ERC-3643 token, it's not your run-of-the-mill everyday meme coin. It's not a standard utility token. It is a purpose-built standard that literally forces compliance right there at the blockchain level. Think of it as a token with a built-in, unyielding regulatory watchdog. It acts as an on-chain enforcer for strict constraints, dealing with things like issuer-managed transfer restrictions, identity attestations, and partitioned balances.
When you actually break it down, ERC-3643 tackles three incredibly heavy regulatory features. First up is authority and governance. Basically, who's the boss? Who is in charge? This defines roles, like the issuer who mints the token or the compliance officer managing the whitelists. Second, we have identity and compliance data. Who is actually trading this thing? This involves KYC status flags, accredited investor badges, and off-chain attestations. And third, programmatic transfer controls. What rules stop them? These are the actual hooks and checks that conditionally allow or just outright block a transfer based on the rules we just laid out.
Moving on to Section 2, the translation mental model. Because to translate this highly specific foreign language into Solana, we are going to need a decoder ring.
We can't just move functions one-to-one. It doesn't work that way. We have to translate the underlying intent. So we use a three-pillar blueprint to break the standard down into bite-sized, manageable pieces. Whenever you look at a feature in ERC-3643, ask yourself this. Is this a role that controls behavior? Is it state that records compliance and balances? Or is it an enforcement point where the actual checks run? Let's sketch out each of these pillars.
First up on the drafting board, roles. On Ethereum, you have actors like issuers or auditors hard-coded right into the contract logic. But on Solana, those actors become explicit public keys, or, far more likely, program-derived authorities, PDAs for short. If a role requires multi-signature control, you're mapping that straight to a governance program or an off-chain multi-sig signer. On Solana, you have to be totally explicit about who has the authority to do what.
Next up is state. Those compliance flags and partitioned balances, well, they need a permanent home on Solana. And you've got a couple of architectural choices here. You could store per-holder compliance flags inside a token account's extension data, which taps into the new Token 2022 features, or you can just use dedicated PDA accounts. What you constantly have to weigh here, and this is a big deal, are the storage costs of keeping that data on-chain versus managing the rent.
Finally, enforcement points. Now this challenge is actually super interesting. Ethereum natively uses transfer hooks right inside the token contract. But Solana's base SPL Token Program, it doesn't have native ERC-style transfer hooks built in the exact same way. So to intercept those transfers and actually run our compliance checks, we usually have to build custom compliance wrapper programs to mediate the transfer or lean heavily into Token 2022 transfer hooks alongside some very careful program logic.
Which leads us perfectly into Section 3, EVM versus SVM mapping. This is where we see the core of our blueprint come to life in a direct engineering showdown. Let's take all these abstract concepts and make them concrete. If you look at issuer authority on the EVM side on Solana, that maps directly to the SPL mint authority or a multisig.
For KYC and whitelists, we move away from smart contract storage and over to PDAs or Token 2022 extensions. Transfer hooks? Those become your compliance wrapper program. Now, when dealing with partitioned balances, like separating locked tokens from unlocked ones, you can either use multiple mints, which really simplifies your accounting, or partitioned PDAs, which centralizes your metadata. And finally, freezing on ERC-3643 maps beautifully, just an elegant one-to-one, to the native SPL token freeze authority.
Next up, Section 4, the upgrade factor. Because if you remember our previous explainer on lifecycle and upgrades, you know that just deploying a program is absolutely not the end of the story.
Let's weigh the operational costs of the architectural choices we just made. Take partitioned balances, for example. If you choose the multiple mints route, you make your supply accounting so much simpler during a program upgrade. But if you choose partitioned PDAs, you centralize your logic, which is great, right? Except it significantly increases your rent burden and the read operations you need. Ultimately, the lifecycle practices we discussed in the last lesson will dictate which of these paths is the safest and most efficient for your specific project.
You got to remember, if your compliance logic is embedded in an upgradable custom program, you are taking on mandatory operational consequences. You DevNet testing complexity, it goes way, way up. You absolutely must create robust rollback plans in case an upgrade just completely fails. And you have to ensure backward compatibility so your off-chain record-keeping systems don't suddenly explode when you push an update. These aren't just minor technical details, these are literal make-or-break business requirements.
Finally, we arrive at Section 5, next steps. We have covered a massive amount of conceptual ground today, drawing out the entire architectural foundation. Now, we prepare to get our hands dirty.
If you take away literally just one thing from this entire explainer, let it be this core engineering principle. Separate roles must map to explicit Solana authorities. By drawing those hard lines, you ensure that your upgrade paths and your key rotation strategies remain completely safe and operational. Security and upgradeability aren't separate features. They are permanently linked in the SVM ecosystem.
So I'll leave you with this provocative thought. When looking at a dense ERC-3643 specification, which operational requirements are you going to map to Solana next? Who mints? Who freezes? What exactly are your KYC rules? I highly encourage you to gather your specific contract excerpts and bring them to our next lesson, where we're going to sit down and do a field-by-field mapping together. Thank you so much for joining me for this explainer. To dive deeper into this subject and explore a ton of other incredible Web3 topics, head on over to forge.college, keep exploring, keep building, and I will see you in the next one.